Hi all, welcome back to semitechtalks. Today we'll have a conversation with Madhusudhan. The conversation will be a mock interview which I'll be taking for 1+ years of experience as is a fresher candidate trained from a training institute very recently. So hope this interview or mock interview will help him and to those as well as for watching this video. So the intention is to make sure that cover all the topics for him and make him understand where he is lagging. And for those who are at the similar state, so that they can improve themselves and be the best in the industry. Okay, let's begin. You ready for the interview?
Yes, sir, ready.
Prepared?
Yes, sir, prepared well.
Okay, relax, man. Don't need to be so tensed. It's okay. It's just a mock interview. Okay. First part.
Okay, sir.
Second part is yeah, I'm recording this. Okay, just for your
Yes,
information, and I'll be
okay, sir.
uploading it on YouTube as I said earlier. Okay, just to
Yeah,
make sure that
okay.
anybody who is in a certain state of preparation will help them. That's it. And you can also watch
Yeah,
your video and understand what mistakes you did. Okay,
okay, sir.
fine, Madhu. Let's begin then. You can start, right?
Yeah, okay, sir.
Yeah.
Right.
No, don't need to be call me sir. Okay. One thing in corporate is you should never call the other person sir. So you have to call them with name. Okay. So you can call me Girish.
Okay,
Okay.
sir. Okay, sir. Okay, Girish.
That's good. Okay. Fine. Let's begin. Okay. Tell me about yourself, Madhu.
Okay, thank you, sir. Thank you for giving me this opportunity to introduce myself. My name is Madhusudhan, and I am from Vizag, Andhra Pradesh. I completed my bachelor's in Amizar College of Engineering in the domain of Electronics and Communication Engineering, and I did two projects in my BTech final year. One is major project, one is minor project. Major project is robot for material handling. After that, I will choose a career in VLSI industry. I will choose physical design course in Takshila Institute of VLSI Technologies. That's all about myself.
Okay. Fine. So one question at the beginning is why did you choose VLSI only? The
Right.
reason.
Through my coursework in my BTech, I think second year, I did one course in NPTEL, that is RTL to GDS flow related to VLSI. At that time, I know the basic idea of that course. So I want to know about how it really works in industry. So that's why at that time I create interest due to that course I done. So that's why I'll choose a physical design course in physical design course.
Good. Good. That's good. Okay. So where did you do your training is from Takshila, right?
Yeah, Takshila Institute.
Okay. So you did your training in physical design only.
Yeah, yes, sir.
Okay. Tell me. So what did you learn in your Takshila in physical design training?
Okay. Actually, we are done two projects through my training. One, those two are in block level chip. One is 32 nanometers and another one is 28 nanometers technology. For 32 nanometers technology, we have 40 macros and 56K plus standard cells with 9 metal layers and 416 megahertz frequency. And another one is 28 nanometers technology. It is a block level chip and it have 40 macros, 50k plus standard cells with 9 metal layers and 400 megahertz frequency. Through these two projects, I have some gain hands-on experience, ASIC flow from floor plan to sign off. Uh, yeah, that's it, sir. These two projects.
Okay. So that's good. So you have at least some good experience. So the tool, what did you use in these two projects?
Yeah, we are using Synopsys ICC2.
Synopsis, ICC2. Good. 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 Okay. So Madhusudan, can you brief me? What does this NM stands in your tech notes? You say 32 NM, 14 NM, and all right. So what does this NM stands for?
Basically, NM stands for nanometers, nanometer technology.
So how does it indicate in your technology node?
Uh, Based on the size of the chip, it defines the technology nodes.
Size of the chip, like what size? How do you say that?
Like the size is decreasing, right? So 32 nanometers, 28 nanometers, 14 nanometers.
Hmm.
It defines the technology node. I have that much of idea about that, sir. That's it.
Mm-hmm. Okay, fine. Okay, so what type of uh, devices or what type of materials are used for your chip design, or means what are their base form? What is this built on?
Yeah, the chips are fabricated using silicon wafers.
Okay,
Mm,
okay, okay. Anything else? Only silicon or anything else?
um, Using silicon wafer and lots of process is there like uh,
No, not
CMOS
about process.
fabrication.
Just asking the materials.
The material used is silicon wafer, sir. I know that.
Oh, okay, fine. So, any other can be used, or is there any other people trying to use it, or only silicon?
As per my understanding, I know silicon, sir. If
And that's
there is
fine.
any, I want to
That's
know
no
about
issues. No
this.
issues. Okay, okay, okay. So fine. So, what do you use as your uh, uh, what do you use this silicon wafers to build? Like, what do you do? You build a diode, transistor? What do you do? Use them?
Yeah, we are not making diodes and transistors. After we are doing all these process, we fabricate this chip on silicon.
Uh, I got that.
For
What logic do you use? Like for example, are you using a, transistor to build your chip? Are you using your resistors, capacitors, diodes? What electronic device do you
uh,
use to build your chip?
yeah, we are using transistors by
Which
using.
one? There are a lot of transistors.
Yeah, right. CMOS,
Okay. Okay. Tell me about
PMOS
CMOS.
and NMOS. Yeah, we are using CMOS transistors in pull up network use PMOS and pull down network use NMOS transistors.
Okay.
Uh, that's it.
Okay. So why do you need? What does CMS stands for?
Complementary metal oxide semiconductor.
Why is it called as complementary?
Because we are using both PMOS and NMOS, right? That's why maybe that is the reason. I'm not sure about this.
Okay. Why can't you use both the PMOS or both the NMOS?
Sorry?
You said that you are going to use PMOS and NMOS, right? In a
Yeah,
combination. So
right.
why can't you use PMOS itself completely, or why can't you use NMOS itself completely?
Basically, we are passing two logics, like logic 0 and logic 1.
Hmm.
We are play with those two logics. So if you only use PMOS, it only passes a strong logic 1, and if you only use NMOS, it only passes a strong logic 0, right? But we
Hmm.
are getting both two logics for efficient functioning, so that
Very good.
why we are use both transistors.
Very good. Okay. Fine. Now we'll get back to some PD. Okay. So tell me, what inputs do you need for your flow plan?
Okay, the inputs for the floor plan is first netlist,
Okay.
then SDC, then def,
Hmm.
technology files, library files, LS file, WLMC file, UPF, um, LF. These are all the inputs for PD floor plans.
Okay. Okay. So assume you are starting your flow plan. So what initially you have loaded your tool. So what would you load first?
First you load the inputs. Actually, sir, what
No, out
happens
of
in I
those
am
inputs, which one is first?
okay. Sorry, can you repeat the question once again, sir?
You said that you will load the inputs, right?
Yeah, right.
Yeah. Out of those inputs, there are multiple inputs you just mentioned.
Yeah.
Out of those, which one will you load first?
Which one you load? It means first you load. I think Netlist, sir, because I am working
Okay.
on scripting,
Mhm.
not debugging, sir. I'm working on scripting and observe those reports how and each stage what happens really. I observe those reports and gain some knowledge, sir.
Okay, that's fine, but inputs is a part, right? You're PD engineer only, right? You're going to be PD engineer, right?
Yes.
Yes. Okay, fine. After netlist, what you will load?
After Netlist, we load def
Which diff?
design. Uh, After getting we from synthesis, we get some def, right? There's an exchange format that we
Synthesis
load.
gives you a def. Sure.
Yeah. Yes.
Mhm. Okay, fine. Okay, def. Then
Then def SDC, then technology
yeah.
library files.
What about left?
Yeah, left is a it nothing but it is a physical abstract view. It contains a information of like cell location, cell names, blockages, rules. This contains a physical layout of the information. It is also provided before we starting a floor plan.
Mm. So, do you load a left or not?
Uh, I am not load, sir.
You will not load.
Yeah,
Okay. Okay, fine. So, do you have macros in your design?
yes, sir.
So, once when you open your floor plan, your macros appear on your screen, right? Outside
Yeah,
your core boundary,
it,
outside your core, it will be sitting outside your core. So, if you press
yeah,
them
right.
and try to place it, it will get placed inside the box in a particular shape and size. So, how do you
Yeah,
get to
right.
know that this shape is this much only, this height is this much only? Which file will you help to get that height and width of that cell or
Uh,
shape? What input should
Basically,
you have
we
to
before
load it to get that data?
mm, defs design exchange format file. In that we define height, width, aspect ratio. These are all things are there in def.
Def.
Yes, sir.
Tell me the difference between def and left.
Left is a def is a physical layout of the design. The main difference is in left contains like information that there no actual routing and no placement, and that is nothing happened. That is layout information like cell name, cell information, blockages. Coming to def, it is a design it is a physical layout of the design. In this def we have placement of cells like information, placement of cells, and wire routing, and placement of map or information. These are all connections there in the def, but every stage we generate a def. This is a difference between left and def. This is a physical abstract view. It is the physical layout of the design.
Okay, fine. Assume you have 15 lefts to be loaded in your design. Okay. These 15
Okay,
lefts depend to a 15 macros, out of which you don't load two of the lefts, you will load the 13 lefts into your design. So on your screen,
okay,
13 macros are appearing. It should be
okay.
15 macros. Where did these two macros go?
Sorry, where these two macros?
Go. Why are they not appearing on your screen?
We are not. I think, as per my understanding, we are not fully loaded the full all left files, right?
Hmm.
We are loading out of 15, we are loading 13, right? So that's why those two macros information are missing.
So now tell me about those macros information. Which file will contain that macros information? Where will it be there?
Macros information, sir.
That physical view.
Uh, physical view. Physical view is there in left.
So without left, you can't get a physical data of it, right?
Yeah. Yes, sir.
So left is needed or not for your floor plan input?
Uh, Left is needed, sir.
Okay, fine. Okay, tell me in your project.
Mm.
So from what state did you start your project? Did you do a partition or you were given a floor plan def?
Actually, we are running every stage. I have a individual scripts, and we are running those scripts and observe the results. And but theoretically, we know what happens in
No,
every
that's
stage.
okay. Madhu, listen, I'll repeat my question.
Okay, sir.
Question is very simple. You are going to
Okay.
start your design. Assume tomorrow I am coming to your institute and asking you to tell me what you are doing. So you'll sit on
Okay.
your in front of your system. First thing what you will do after loading the tool and all, what thing will you
Yes.
load? Like, are you going to do after loading all the input? Once you open that, you will have your design loaded, or is it like you have to do a partition and then load it? Give aspect ratio, give the size and height of it, or like that.
Directly we load the designs by using
So you
scripts.
you will have that shape and width height already defined.
Yeah, yes, already defined.
Okay, so just by sourcing script, you'll observe that changes.
Yeah, yeah, right, sir, right.
Okay, have you ever checked the script? What is there inside the script?
Yeah, check, sir, check it.
Okay, tell me what is there in your floor plan script to understand so that what changes you have observed.
Yeah, in that script, we are understanding placement of macros.
Hmm.
Uh, After that, in floor plan script, we have a power plan information and physical only cells. These are all information there in that script.
Hmm.
We run. We are running individually also, right? Floor plan and power plan, and we are running and observing how the partition happens, and after that partition, how the macros are placed, and after that, how the power plan. Individually, you have run and observe
Okay.
those scripts.
Okay, fine. Now, tell me what is that one command in your tool that will uh, define the area of your block.
Define the area of the block. Before starting with floor plan, we give aspect ratio, height, and width. Set
Command for that.
the command. Here, coming to command, set placement hyphen core utilization ratio, and another one is set placement hyphen aspect ratio. These
Okay.
two commands are defined the height and width, sir.
How? See, you're not defining X value or not defining Y value. Just defining the aspect ratio. That is, it might be 1 is to 2, 2 is to 4, 1 is to 3, like that. Okay. And
Yeah,
core utilization you're defining. So your
yeah,
utilization will be defined, but no height, width,
yeah,
length, anything. So what command do you use for them?
yeah. Mm,
You're lagging, Madhu.
command, uh,
You're lagging.
for defining the height and width, sir.
Hmm.
Now okay. Now okay, sir.
Hmm.
Hello, hello,
Yeah, good.
sir.
Tell
Now
me.
it is now audible, sir.
Yeah, audible. Tell.
Yeah, you are asking about height and width.
How do you define your height and width in your floor plan?
We define by using those two comments, right? Set placement, core utilization ratio means
Hmm.
we define some percentage for utilization, and we
That's
define
okay.
aspect
See,
ratio like one.
understood. But
Yeah,
there is nothing like height and width definition in them, right? You are defining utilization ratio and you are defining the aspect ratio. There is nothing like height or
Yeah,
width,
right, sir.
right? So there is one command
Mm,
in Cadence
right.
Innovis where you can write your floor plan data, floor plan, specify floor plan, and you can just give the width and height, and you can give the die to core area spacing. So what is that command in Innovus?
I don't know about Innovus, sir. In synopsis, I
No, no,
think.
I gave an example of Innovus. I'm asking about Innovus
Okay,
synopsis only.
okay, okay,
ICC2 or FC.
okay. Right now, I am not recollect, sir. I
Fine,
want to
that's
know
okay.
about this thing.
Fine, that's okay. Fine. Okay, tell me. So in your floor plan, what do you exactly do? Just tell me in 3 to 5 lines.
First, we define the core utilization and aspect ratio. Then we define the IO ports. After that, uh, placement of macros according to the macro placement guidelines. After placement of macros done, then we go to a power plan and we create a power plan. And in during floor plan stage also, we insert some physical only cells. These are the three steps involved in the floor planning.
Okay, what do you mean by physical only cells?
Physical only cells, it basically doesn't have any functionality.
Hmm.
For example, like tab cells, and cap cells, filler cells, decap cells, tie cells, these are all the physical only cells. These are all have individual functionality, and these are all used for some specific purpose, and they don't have any functionality.
Okay. Also, what do you mean by what is actually tap cell used for and what is its functionality?
Yeah, basically, they have power and ground connections. Tap cells are used to avoid a latch up effect.
Okay, now define latch up effect. What do you mean by latch up effect?
Yeah, right. Latch up effect means inside CMOS fabrication, some unwanted transistors are created together, and these unwanted transistors are connected together and form a short circuit path between VDD and VSS, power and ground. Uh, Due to the short circuit path, the chip may suddenly get very high current. Due to this, the chip may get hot or maybe chance of failure. Uh, to avoid this, we using tap cells um, in floor plan stage in a checkerboard fashion.
Okay. Now, how are these unwanted transistors getting done in fabrication? You just said that there are unwanted transistors getting there, right? So how are these coming
Right.
into picture?
Uh, Sir, no idea, sir. I want to know about this thing.
Okay, good, fine. And okay, now how will this tap cell prevent this issue? How will it avoid the latch up effect?
It it stops the short circuit currents. It tap cells is
How?
yeah, it connected to power and ground, right? So these tap cells acts like a to avoid to not avoid to block the short circuit current whenever we connected to power and ground and to the tap cells.
I think fine. Okay. Now, okay, what was the width and height of your block?
Height and width is aspect ratio is one.
Height and
So
width, the left to right and top to bottom. Did you measure?
no, sir, I am not measure.
You have to measure, right? You are doing a block,
Yeah, right, sir.
right? Okay, keep a note of it. Then we'll
Okay,
come
sir.
back to floor plan. Okay, so fine. Now tell me what exactly do you do in your power plan? Why is that state needed?
After floor plan, we create a power plan because we give power to the all cells in the design.
Hmm.
So we create a power plan first, first we create VDD and VSS power pads, then core ring, then global mesh. Then this is the flow of the how the power goes to the cells,
Hmm.
and after global mesh it is going to pins of a cells. By using three commands, we create a power plan. Like first, we create set PG. I think set PG strategy, compile PG strategy, create PGVS. These are the three commands used for to create floor plan.
Okay.
That's
So
it, sir.
now tell me, what is the spacing you decide between two macros? How do you decide the spacing between the two macros? You give a channel spacing, right, between two macros.
Yeah,
How?
yeah, yeah. Yeah, yeah. Basically, what happens means I observe the channel space, but I am not giving channel space because I run the scripts and I observe. But that how you give the channel space means we have one formula for the channel spacing number of pins into pitch by available total metal layers. By using this formula, we give a channel spacing between cells.
Okay. Now I'll tell you, you can't use this formula. Is there any other way where you can decide the spacing between the channel, between two macros or channel
Yeah, right.
spacing?
Yeah, right. We can use NDR rules.
No, NDR is not
Sorry,
feasible.
NDR, not. Okay. Mm, Without using channel spacing. No idea, sir. I want to know about this thing.
Okay. So, okay, now you are going to create your PG grid, right? Power and ground grid. So,
Yes, yes.
what is that one criteria that you need to follow to make sure that your PG grid is unified and is going to provide the power to everything?
Yeah, right.
What is that one thing you have to follow?
One thing means what, sir? I didn't get the question, sir.
So, you are going to do a PG, right? PG grid. That is your power planning.
Yeah, right.
So, what is the purpose of your power planning?
The main purpose is to provide the power to all in the design for
Hmm.
all the cells.
How will it be provided?
Yeah, we create power grid structure, right, in
Hmm.
power plant stage.
Hmm.
Through this, we can give power to all the cells in the design.
Okay. Now I'll ask you this one question. You can see my whiteboard, right? It is loading. Wait.
Loading, sir.
So this is your block, assume.
Okay.
Okay. So now this is your power grid. The horizontal straps and this is vertical straps. Okay.
Okay,
Right?
sir. Okay, right.
So how are you deciding the spacing between these two straps and these two straps? On what basis?
On what basis? Mm, As per my understanding, I think these power spacing and width is defined in the files. I think
Hmm.
I don't know about. I am not sure, but these information are present in files. I think.
Hmm. So how do they decide?
How do they decide? Means. mm, in I think in lower metal layers you are placing standard cells, right?
Okay.
In lower metal layers, so resistance is more and width is less. This is the inversion higher metal layers. Based on those criteria, we give width. Lower metal layers standard cells, then signal routing, then clock routing happens, right? Based on the criteria, we decide those straps width, I think.
Hmm.
I'm not sure, but I want to know about these
Okay.
things.
Okay. Okay. No issues. Fine.
Yeah.
Now we'll come back to uh, next thing is your placement. Okay. Tell me what stages does placement include and what do you do in your placement stage?
Yeah. Coming to placement after floor plan and power plan, then we do a placement stage. In placement stage, what happens means placement of standard cells in a legalizer locations. First, there's actually five stages. First is initial place opt. In place opt, we have five stages: initial place, initial DRC, initial opto, then final place, and final opto. These are the five stages happen in place opt. Based on these, the standard cells are placed in legalized locations.
Hmm. Okay. So
Can
how does
I?
your, yeah, tell me something. You were about to tell something.
No, no, no. Can I explain what happens in each every stage, sir?
That's enough. I'll ask it. Don't have much
Okay.
time, right? So we'll get to know what you're understanding. Now,
Okay.
your cells are being placed. Okay, assume your cells are being placed. So how are
Okay.
these cells getting placed there? Like what way it gets and what way it takes to get placed there? Assume if a cell is sitting at the left corner, why is it going and sitting at left corner? It can sit at the right corner also, at the center also.
You're right.
So why does it go and sit at the particular place only?
Based on the communication of the cells by through virtual connections, macro to macro communication, macro to cells communication. So same type of macro modules with cells placed together. So based on that communication, the cells are placed near to that macros. Based on that, we will fix that location left, right, and
Okay. So what do you call these type of placement as?
first. First, we are doing course placement.
No,
Maybe
no,
in
no,
this
no,
course,
not that. It's not course
okay.
placement. What this is a type of placement, what you said right now. We call it a name. Okay. What type of placement is called this? Like this is called as some dash type of placement.
Type of placement. Sorry, I didn't get that question, sir.
So you
Correctly.
just said that this is going to be placed here because of the communication, etc. and all, right?
Yeah, right, right.
Okay. So what type of, there is a naming for this type of placement?
Module placement.
No, no. Module placement is different, right? Module placement is your macro. Just place your
Yeah,
macros. That is called module placement.
different, right? But say macro related cells are placed near to that macros, right?
Why? You tell me why the macro related cells need to be placed near to them. What advantage will it give me?
Yeah, if you are placing away from that, we get routing and congestion issues. If you place near that macro communication ports, we have less. Don't. It's not like that. Not demand for routing. We are easy for routing, and we are not getting congestion if you place near that macros
Okay.
related cells.
Two questions now. Congestion will get anyhow, even if you place them close also, you are going to get congestion. You are going to, if you place outside also, you're going to get congestion. Assume if there is no
Yeah.
proper spacing, okay? Or if there is no
Yeah.
much area, that's okay. Second thing is, what will happen if you place closed and if you are able to route easily? Why do you want to route easily? What is the advantage you are going to get if you route them easily?
Whenever you are placing cells nearly, can you repeat the question, sir, once again?
You said you are going to place cells closely to your macro.
Yeah, right.
If you place them closely to your macro, what is the
Mm.
advantage you are going to get? You said routing. You can
Yeah,
have a
yes.
routing easy. So if the routing happens easy, what is the advantage you are going to get again?
Mm, if you place near to the communication of the macros, uh, main advantage is routing, but another one I think, no, sir, I want to.
Fine. We were talking about the placements, right?
Yeah,
Okay.
right.
Now tell me. So you are getting congestion in your block. How do you resolve them?
Sir, my voice audible, sir?
Yeah, your voice is audible. Screen is a bit freezing. That's okay.
Oh, okay, sir. No, okay, sir.
Now
Hello.
it's still freezing.
So,
It's freezing, Madhu. It's okay. Continue. It's okay. We just need the audio to understand your words. So it's okay. Fine. Continue. So tell me, you're getting a congestion in your block. What steps would you take to resolve them?
first, if you get congestion, basically, if you have high cell density, we will get a congestion. And another reason, if you have pin density, we will get a congestion. For that high cell density, we use proper placement blockage to avoid congestion. If you get a high pin density, we use proper cell spacing to avoid this congestion.
Okay. Now you talked about placement blockage. So what does this placement blockage will do and how will it help you resolve the congestion?
Placement blockage, actually there are three types of placement blockage: soft, hard, and partial. Based on those, if you use hard placement blockage, and there is no cells placed in that blockage, in which created region. If you create a soft placement blockage, only buffers and inverters are allowed in the created placement blockage. If you use partial placement blockage, based on those given percentage, the cells are placed. So based on those requirement, we use these placement blockages by using commands in ICC2. Through this, we can avoid the congestion.
Mm. So is there any other ways you would use to avoid the congestion?
Uh, yeah, we use cell spacing
Okay, how do you do that?
by using commands like set, placement,
Understood.
spacing label.
Are you going to give cell spacing to every cell?
Not every cell. I think a group of cells we mentioned in that command.
Hmm. Why?
Why? Sorry, sir. To avoid congestion.
Okay, that I know, but why only a group of cell? Why not all the cell?
Group, not individual. Sorry, can you repeat the question again, sir?
Okay, the question is, you said that the question was, is there any other way to resolve the congestion? You said that you are going to provide the cell padding or inch padding, something padding, or I mean, you are going to give the padding. So for all the cells, are you going to give for that? You said no, only a particular group. Why you only do a particular group? Why not to all the cells?
We are giving all some specific number of cells.
Hmm.
We are mentioning in that cell, not for individual
But
cells.
why for only specific cells? That is what my question was.
Okay. Uh, because cell density is more, means it more cells are sitting together. That's why you are splitting those cells. So for that, we use a number of cells, not only individual cells. We get a congestion. We get a congestion whenever the more cells are sitting together. So for spreading, we are using that blockages, not for individual cells, I think.
Okay, fine. Now, okay, assume now you are done with your placement stage. So,
Okay.
what are the checks you are going to do after your placement is done?
Yeah. Okay. After placement, we check first legalization, whether the cells is in legal locations or not. Then we check PZ grid connectivity for standard cells, and then we check congestion, report congestion, utilization, and we check timing. These are all the checks we have done after done we are placement, and also we check whether we applied don't touch cells and nets applied properly or not, which are given in the don't touch list. These are all the checks done after the placement stage.
Okay, now you just spoken about the timing, right? What would you check in your timing after your placement? What checks would you do at timing?
Yeah, basically there are two types of timings: setup time and hold time. In placement stage, we check setup time.
Okay, what do you observe there? Checking setup means what checks will you do in setup? What is the numbers you got?
Uh, Actually, after run those scripts, I observed there is very small slack. I observed negative in minus 0.2, not that much of slack. Setup slack I observed in minus 0.2, minus 0.3, I think. So very small slack I get after running the script.
So you mean to say that your setup was already fixed after doing a placement?
Yeah, almost fixed. There is a small setup slack,
Okay,
not that much violation I observed in this stage.
okay. Then what about the hold?
Basically, whole we are check after CTS because in placement stage we are not build a real clock, right? That's why we are not checking hold at the placement stage
But can you
because
check?
we are sorry,
But can you observe the hold timing after placement?
after placement uh, not observe.
You're not observing, but can you observe?
Yeah, observe, sir. Observe it. Can you, is a possibility to observe the whole.
Hmm, okay, fine. Now tell me, you are into CTS. Okay.
Okay, sir.
So before coming to CTS, do you analyze anything else apart from all of these checks what you have mentioned?
Mhm. Apart from these checks, we observe legalization, congestion. These are all things okay. Almost these checks are done before we go into CDS. Mm, yeah, almost these checks are done, sir, before going to CDS.
Before
If there is any,
placement, is there anything else check that you are going to do apart from whatever the checks you mentioned before placement? That is after your power plan.
checks before placements.
Hmm.
Yeah, okay. Check whether the play macros are placed properly or not, and whether we create power grid proper utilization. Uh, mm, Next, and make sure that clock is set to be ideal or not. These are all the checks we have done after before we go starting placement stage.
Okay, but after placement, you are not doing any different additional checks apart from what you have mentioned, right? So anything with respect to the power you are going to check?
Yeah, we check PG power grid connectivity for standard cells.
That's for connectivity, not about the connectivity. Anything
Yeah,
else?
anything, right now, if there is any, maybe I am not recollect right now, sir. I
Anything
want to
like
know.
power drop, IR drop?
Yeah, basically in play airdrop. Yeah, we check airdrop, but I'm not sure. I'm not sure that because I'm not checking any airdrop issues, so I'm not recollecting right now, sir.
Fine. Okay. Tell me what do you do in CTS and why is CTS needed in your design?
Yeah, after placement of standard cells, we build a clock for those all cells in the design. In CTS, what happens means build a clock for all those cells with minimize skew and latency. Uh, based on this, we create a proper clock tree structure uh, for equally distributing the clock to all the cells in the design.
Okay. So by doing this, what will happen? What advantage will you get?
Yeah, the clock is built. Clock is equally built for all cells in the design. With minimized skew and latency with the minimum power dissipation and area. So this is happens in CTS.
Okay, fine. But you could do anything else also, right? It's not that you have to build the only clock tree for that.
Yes.
So what else? Main advantage what you are going to get in clock tree by building the clock tree. Even if you don't
Yes,
build a clock tree also, you'll get the clock connectivity to all the cells from your clock pin. You can
yes.
connect directly also. Why you need a clock tree?
Why you needed clock tree means to build a clock for all the cells in the design.
See, Madhu, now you are at one point.
Mm,
Okay, that point is called as clock point. There are a lot of cells sitting in your design.
yes,
Each cell will get a clock from your clock
yeah,
pin. Okay, that's not a problem. You'll still get a clock signal to all
okay.
the pins. But why do you have to build a clock tree to get the signal to all of those clock pins? Why you need a clock tree? That is what my question is. Without building a clock tree also, you'll get a clock signal. With building a clock tree also, you'll get a signal. Why do you have to build a clock tree?
Why do in clock tree we use special cells, right? Compared to normal, we use clock buffers and inverters, and some special cells are used in clock tree. Without using clock tree, we can't insert those special cells like clock buffers and inverters. Normal buffers or inverters, maybe we are inserting without clock tree. So by using this clock tree, we can effectively build a clock for all cells.
Fine. Okay. Now, okay, you said about skew and all, right? What do you mean by skew?
Skew means it is the arrival difference between arrival times of two flops. For
Very
example,
good.
launch and capture flop.
Okay. So, what do you mean by a slack then?
Sorry, slack, sir.
Hmm.
Slack is nothing but uh, how much the violation is happens for that particular timing violations, like setup slack and hold slack. If you get a negative value, it should be mentioned as you get a violation for that setup violation.
What do you mean by latency?
Latency means the time taken for the clock to reach from clock source to CB pin of the flops.
That's clock latency. I'm just asking latency.
Latency means time arriving, the difference of the time taken to reach from clock source to CP pin of the flops. The difference from
That
clock
is,
source to
again, you are
sync pin.
talking about clock latency.
Okay.
I'm asking about what do you mean by latency? Define latency.
Latency is nothing but how much time it taken to travel uh, from clock source from source to CP pin. It's also mentioned by
Okay, fine.
particular
What do you mean
latency
by
means,
a delay?
not delay. Delay means how much for example, delay means how much time it taken to travel from it um, like delay in how much time it takes to travel from one point to another point. The time taken.
Okay. What do you mean by setup time?
The minimum amount of time data should be stable before the clock edge is called setup time.
Which clock edge?
Each
Your
clock
clock has
edge
two clock edges, right?
uh, each clock edge means before the falling edge.
You can have a falling edge clock also. It's not like that.
Uh, uh,
You can have for rising edge also, falling edge also. It's about how you design your device to be this. So data has to be stable before which clock edge? That is what I'm asking.
Before which clock is means capture clock is.
Mhm. Assume your clock tree is built on a negative clock edge. So when will you launch
Okay.
your data? Or when should
Negative.
your data should be stable? So let me draw a whiteboard for you. See, this is your this is your positive edge, this is your negative edge, right?
Okay, sir.
Now tell me, your data needs to be stable. Where? On which clock edge? Should it has to be stable here or here? This is the first
Before
and this is the
before the first before the first one.
before the first one. But I'm launching the
Yeah.
data at here because my clock is inverted clock
Okay.
and my even flop is inverted. Now tell me,
Okay.
or assume will not go for inverted clock, you will go for regular clock, but my Q is inverted, or I am going to launch at the negative edge. Now tell me, where should the data be stable?
For negative edge, the data um, before the negative edge, sir. I'm
Hmm.
not sure, but I think before the negative edge, the data should be stable.
Why? Here you are saying, okay, why?
Yeah, that's
Why?
because if you the data should be stable before the clock, uh, the data should be stored properly.
Stored.
Yes.
Okay, now tell me, what do you mean by hold time?
The minimum amount of time data should be stable after the clock edge,
Which clock edge again?
after the falling edge.
Here. Assume I am capturing on the positive edge. Now where should be the data stable?
Can you draw the another way?
So this is the
Explain.
waveform. This is the falling. This is the rising. Okay.
Okay.
So you just said that the data needs to be stable for some time after the falling clock
Clock
edge.
edge.
Now I am
Yeah,
changing
right.
the condition where I'll capture at the rising edge. Now where should be the data be stable?
Sorry, can you repeat, sir?
You said that the data needs to be stable after the clock edge, right?
Yeah, right.
Which clock edge?
After the falling edge.
After the falling edge. Okay, now I am
Yeah.
going to capture the data at
Mm.
the rising edge only, not at the falling edge. Where should be the data be stable? After which edge?
Mm. After the rising edge, right?
After rising edge. Here.
Mm.
So now define me, what do you mean by setup and hold after all of this analysis?
For setup, the data should be stable before the clock edge. For hold, the data should be stable after the clock edge.
Which clock edge? You have to tell it as active
Mm.
edge,
Okay,
right?
okay. Uh,
Active edge might be
for
a
set,
rising edge also, falling edge also.
yeah, right.
Fine.
For
Okay,
setup, that
that's okay. Now we'll go for routing. Tell me, what do you know about routing? Why is routing essential? What all things will you consider in routing?
yeah. After building the clock tree, we come to route stage. In route stage, we build a signal routing in three stages. First, um, uh, global route, then track assignment, then detail route. Under three stages, we build a we route the signals for all cells in the design.
Okay, fine. So only clock signals, only signals you will route, only the signals routing you will do, or any clock routing will be done here.
In signal routing is done in route stage.
Clock signal routing then?
Yeah, clock signal routing.
Okay. So your clock signal routing will also be done, huh?
Yeah, maybe. I'm not sure.
Mm,
Signal routing is done. Uh, uh, yeah, signal routing is done in route stage.
But you consider clock as not a signal. Clock signal is a signal or not?
Clock clock is a signal set.
Then clock signal routing will be done separately or with this only?
In route stage.
Uh, So what do you mean by NDR then?
NDR is nothing but non-default routing, like a double space, double width. These rules we are applied to avoid crosstalk and AM issues,
What do
electron
you mean by
migration issues.
crosstalk?
Crosstalk means the switching of a signal interfere with neighboring nets due to cross coupling capacitance. The crosstalk will happen. Crosstalk noise and the
Yeah, what do you
crosstalk
mean
delay.
by coupling capacitance? What is the difference between coupling capacitance and normal capacitance?
A coupling capacitance means it happens between two capacitors, right? Whether in parallel or in a series. The capacitance happens between those two parallel or series. This is called coupling capacitance. And normal capacitance means having a some capacitance for that capacitor, right? That is the normal capacitance. It is defined for normal capacitor, and the main difference is the coupling capacitance happens between two nets.
You sure about it?
Yeah, sure.
So how is this capacitance coming into your chip? What is it has to do with the chip? How is it coming inside a chip?
How is it coming inside a chip means yeah, for every metal layers we have metal layers, right? We have for that metal layers we have resistance and capacitance. Based on those we place those cells, and based on their power airdrop, these fan out, these are all included based on the resistance and capacitance, right?
Very
That's in this way the capacitance comes in the matter.
good, good. Okay, fine. So what do you mean by an R and C extraction?
Resistance and capacitance. I know. I just hear that word, sir, but no, I don't know about this thing. I want to know about this.
Okay, now tell me one
Okay.
scenario I'll give, practical scenario. Assume there is a two cells, cell A and cell B. Between them there is a routing happening, but due to some routing happening at the layer M5, you have total 12 metal layers, out of which this routing is happening at the metal 5 layer, and the timing is
Metal five.
not
Okay.
meeting because of the timing is not meeting between these two. Hold is meeting, and we have a hold margin also. Setup time is
Okay.
failing. Routing is happening at the fifth
Okay.
metal layer. What would you do in routing in such a way that this timing is going to be met, the setup timing?
Timing. If you routing in higher metal layers, it is in higher metal layers the resistance is very less, right? That's why delay will be less. It is better for setup. So the if you done routing in higher metal layers, we will met a setup time.
Which metal layer would you choose?
Higher metal layers.
High means what? Which are those higher? Out of 12, which one will you choose?
Yeah, out of those 12 in power, 12, 11, 9 and 10 metal layers.
Why only 9 and 10?
11 and 12 metal layers are preferred for power, right? That's
Hmm.
why after power we are mentioning for these routing layers. After
So,
higher
okay,
metal
fine,
layers are preferred for power.
fine.
Yeah,
Don't you think if you route in metal 10, your hold will violate for the same path?
yeah, maybe hold will violate, sir.
So it's a waste, right? You are trying to fix setup and violating the hold. So how will
Yeah.
you decide which metal layer to route then?
basically it's hard to met compared to hold. So for first we prefer setup fix. Hold is we can add buffer, then hold is met easily. So
But
that's
still,
why
see,
first we
to meet a hold, you are going to add a buffer. Where you are going to add a buffer?
yeah, right.
Again on the data path,
Yeah, right.
right? Again,
Data
you are
path.
going to delay the connection between them. So again, you are going to violate the setup. So this becomes to and fro, right?
Yeah,
So how can you
yeah, okay.
balancedly fix both of them?
Yeah, okay. Before we fixing hold, we check setup margin, right? Based on the setup margin, we can fix hold
That is what I
without.
am telling. See, I'll repeat the question for you again. Two
Okay, sir.
cells, cell A and cell B are there. Both are sitting at some distance. The routing is happening in metal 5 for this. On this routing, hold is fixed. Okay. You have some margin. Assume
Okay,
25 picoseconds of margin for your 20 picoseconds of margin for your this line, this path in hold. But setup is
okay.
violating. Okay. Now you said that you'll route in the top metal layer. So you chose metal 10.
Yes.
So if you route in metal 10, don't you feel like the hold will be violated again? Because it is already fixed. If you just by making it route in top metal layer, you are going to violate your hold. So what other way would you do, or what other metal layer would you choose to fix them?
Other metal layers you are asking, right?
Uh, can you do it in other metal layers?
No, sir. We are routing in top metal layers 9 and 10.
Then your hold
If
will
you,
violate.
yeah, you hold we violate, we will uh, add another. Sorry, we will choose another technique for fixing
What
hold
would you choose?
without disturbing the setups
What would you
like
choose?
yeah, you are using swapping of VT flavors.
If you swap a VT flavor, again you are degrading your setup. Means your dry strength or the speed of your signal passing in that metal layer. So again, you're affecting your setup.
Right. Mm.
Fine, it's okay. You have to prepare for this.
Okay, sir. Okay.
Okay. Now, one last question. What do you mean by ECOs? ECO, and what do you do?
Yeah, right.
What idea do you have on ECOs?
ECO is nothing but engineering change order. At the after like after BTO, I think I hear that what BTO based about. If there is any logic changes or any component mismatch or any some logic we want to add, we use those spare cells and we insert spare cells. By using those spare cells, we can uh, run those logic, and if there is any fixes, timing fixes, setup and hold fixes, final fixes. In ECO stage, we are all these fixes. By if there is any functionality change, we use those pair cells.
Okay, fine. So, okay, what do you do if you are getting a lot of DRCs? How would you fix them? And what might be the reason for a lot of DRC?
The main reason I think why we getting more DRCs means if you have a high cell density hotspots or high pin density hotspots or insufficient floor plan, and if you have metal layer density violations or base layer density violations, or if you are not getting correct aspect ratio, incorrect floor plan without following macro placement guidelines. These are all the reasons for we are getting high DRCs, I think.
Okay, what kind of DRCs would you see? What kind of DRCs, type of DRCs you would see?
Spacing with
Only those two.
spacing with via cell, not cell entities. Yeah, two are more there, but right now I'm not recollecting stuff.
Okay, fine,
Spacing with these are the violations.
fine. That's okay. Okay, Madhu. So this is the end of the questions I'm going to ask. So we'll just
Okay, sir.
revise your interview. Okay. So I'll just give you a very good feedback, whichever I feel is needed for you, so you can understand. So I'll just share any of this
Okay, okay.
video will be uploaded on YouTube, so you can just revisit and understand your knowledge. And don't worry, you're given your best, and this is sufficient for entry level. But you need to improve more. Okay, so I'll tell you everything where to improve. Be
Okay.
ready for it and improve yourself. Okay. So first thing is nanometer question. I asked you what does NM stands for. So NM stands for
Correct.
nanometer. So you said that the chip size and all. It's not about chip size. It's the spacing between the source to drain, the channel, right? You have a
Yes.
channel, right? The source to drain,
Right.
you have a channel where your current flows from source to drain. So the
Yeah.
channel
Right.
width is called as nanometer. So if you have a 3 nm means channel between the source to drain is 3 nanometer. 5 nanometer is then 10 nanometer. Why we go lower
Right.
nanometer is for lower power. So if you are having a 3 nm, the spacing between them is less. So you don't need high current. That is ID versus your VGS, gate to source voltage versus the drain current. The flow of current will be fast, means it needs to travel very less time, less area or less space, so it will flow properly. This is what NM. So try to understand regarding that. Okay. And variety
Okay.
of
Okay, sir.
materials. I asked you about what type of materials are they going to use. You said about only
Yeah. Right.
silicon. Understand
Right.
there is one very prestigious institute called IISc Bangalore, right? So they have recently
Yeah. Right.
posted one material called as gallium iridium combination, so that might come into market. So keep updated about this news, this will help you. Okay, so there
Okay.
is even other materials also coming into game, but yeah, silicon is the best answer what you said. There are others also. I have a idea about this. Keep reading about semiconductor news, you will get to know. Okay, then we are going
Okay,
for
sir.
CMOS. You get a very good answers for CMOS. You gave why CMOS, what do you mean by CMOS, PMOS and NMOS. I really appreciate that knowledge you have, that is really good. Okay, if possible study
Okay.
even more bit about semiconductor physics, like what is
Okay.
valence electron, what is covalent bonds, all of this. That will help you understand the basics. So you can understand everything in your routing and congestion, placement, CTS, everything. Okay. The question what you
Okay.
answered for CMOS answer for the question of CMOS was really good. Okay. Why you call it as complementary, PMOS, NMOS, pull up, pull down. That was and the logic of zero, and that was really good. That's a plus point for you. Okay. Then
Okay.
we'll come to your main. See, when I ask you about tell me about yourself and introduce, you have to be very clean and neat, which doesn't say sufficient information. So assume you are a Madhusudan, how you have to tell your introduction? Myself Madhusudan, I'm from this city. So tell your full name. This is Madhusudan so and so. I am from this city. I've recently completed my graduation in so and so. After that, I did my VLSI training from so and so institute. Before that, I did my intermediate and schooling from so and so. And I have interest in this field because of this reason. And I have so and so hobbies, and I'm ready to contribute to your company for this role. That's it. That introduction has to be 3 minutes. And one more thing, you try to improve your fluency in English. Okay, so you're losing the
Okay.
touch, and you're getting some of the words from other languages also. That's okay, that happens, but try to improve. Watch some good English podcasts, listen to them, or watch some English good movies. Read the subtitles, read some books, read some news. That will help you. You're really good at it already, but yeah, I'm giving one more point to add up. Okay,
Yeah. Right.
then
Okay.
the thing what you said about the motive to enter VLSI. I asked why do you want to enter VLSI, right? You just said that I
Yeah.
had done this project and so I was curious. That's good point. Keep it going. That will help you because you need to have a strong motive to enter VLSI. Only then you can sustain. You have that, you can go ahead and try to
Right. So,
understand the difference between left and def. Left is a must point in your floor plan inputs. Def is the thing you will give to other synthesis team after your floor plan. Def is nothing like a screenshot of your something, but left is like
yeah.
a physical view, means it needs a data. Assume you loaded 15 left, 15 left data will be appearing on your screen. If you don't load a left, as I asked a question, you'll have 13, you load only 13 left, so you'll only get 13 macro, means each macro will have a left, macro left will be there, tech left will be there. Okay, so Sit and read about the left and def. Okay. And all the
Okay,
inputs you
sir.
have to read. .v, SDC, left, def, timing constraints, non-timing constraints, DRC, DRV, everything you read. That understanding if you get, you will be strong in your inputs and really good at it. Okay. The latch up effect, you gave a good answer, but you need to understand more about latch up effect. Okay. You
Okay,
need
right.
to
Right.
understand even more. Depth needs to be there. And first thing is I give more stress on this. Understand and learn everything about physical only cells.
Okay.
Okay, that is really needed. That is really, really important for you. Okay, physical only cells. Not only me, any interview will ask you about the physical only cells. Even if you are a 1+ engineer, 3+ engineer, 5+ engineer, they are going to throw this question at you. Okay. Then power spacing.
Okay.
I said you right. How do you calculate the channel between your macros? You just said that I'll
Yeah,
use
right.
pins, etc. There is
Yeah.
one criteria. At least one VDD and VSS strap, a set of VDD and VSS strap has to pass on your macro or on a cell that is having a minimum width. So that is one thing you have to
Okay.
consider. So by that way also you can decide the spacing between your VDD VSS set to VDD VSS set. Okay, that is
Okay.
pitch. Okay, that
Yeah,
one thing
right.
you have to understand. Then you have the
Okay, sir.
cell placement reasons. I'm asking why do the cells getting placed there? What are the reasons, cells, etc. and all. That also you have to understand. Why? Right?
Right.
So that is I even asked you what type of placement is it called as, right? That's
Yes.
whatever you said is a timing driven placement. There
Right.
is one
Right.
more thing called as congestion driven placement, right?
Right, sir.
While giving the commands, you will give hyphen timing, hyphen incremental, hyphen so and so. So those commands, see that knowledge you need to gain. Okay, that will help you because
Yeah.
placement placement is a very important stage in your complete PNR. Then you are going for specialization in all area. Yeah, so you have to understand all the things. Floor plan you have to go through, power plan, placement, CTS, routing, all the area you are a bit lagging. Okay, can still do well, do it. Okay,
Right.
then yeah, setup and hold concepts you have to improve. What you said is good. If I twist a question, you'll be confused, right? Don't do that because expectations are high. So if I ask you that question in a twisted way, try to understand the question. Take your time, take 1 or 2 minutes or at least 5-10 seconds and try to regain what you can and then answer. Okay. Then
Okay.
routing
Okay.
and clock signal part you have to understand. So routing you have given good answer, but what is exactly routing happening? How is it happening? You have to mention about the global route GRC in the placement stage. You have to mention the estimated routing, actual routing difference. Those things you have to speak. And capacitance,
Okay,
you
sir.
said right. What is the difference between the coupling capacitance? That is wrong. Okay, means
Okay.
wrong in the sense
Okay.
that's kind of half knowledge. Go and check on it, learn more about it. Okay, capacitance is the important scenario you have to talk. And in that you have said one more thing. I asked you about a routing. How do you calculate R and C? Why? How is the capacitance coming into game? You gave a very good answer for that because the we have a net length. It has resistance and capacitance. All of this. That's a really good answer. These answers will be highlighted. Means that gives the interview understand that this person has the knowledge about the basics. Okay, and then try to read more and more practical scenario questions on the internet. There are a lot of websites available. Try to answer yourself for the interview questions that are available on the internet. Okay,
Okay, sir. Okay.
go check. There are a lot of websites. Try to give 1+2+ engineer interview questions. Okay, and ECO
Okay, sir.
happens after routing only, not at the BTO. ECO routing afterwards, you'll do ECO for timing and DRV DRC fixes, then you do a BTO, then you do a MTO, and then you give it to the final tape out. Okay, these are the
Right, sir.
areas
Right.
which I have observed. And
Mm.
see, if I have to rate you, you are at 6.5 out of 10. Okay,
Okay, sir.
bit of more clarity or 2-3 rounds of revision. Last thing I wanted to speak is that BTO, yeah, ECOs will happen before BTO, and once that ECOs are for timing, DRC, DRV fixing, and even the PDN fixing. Once that is done, you're going for the BTO, and after base tape out is done, you'll have some few violations you will be fixing through MTO. So after that, you'll give your database to your the other team, like the sign off team. That's it. So this is all about your interview and its revision and the topics which you need to focus. So first thing is have some more confidence. You'll gain it very uh, through the flow or very easily through the flow. So what thing I would advise you is to sit and give interviews to yourself, make a list of questions, turn on the camera, record yourself, and start answering those questions properly, and then analyze. You will only understand where you are lagging. Okay, so that way you can build
Okay.
your confidence, fluency in English, and understanding of the concepts also. So that's one
Okay,
thing.
sir.
Rest all you're good, man. Say I can rate you around 6.5 out of 10. So remaining why I'm not giving is that you still have the room for improvement. The scope of improvement is there. So I would rate this much. Can come back and give your mock interview again after a month. So I'll rate you again. So you need to have an improvement in them. So this is about
Thank you.
all from my side. Anything else questions you have, you can ask. Whatever the knowledge I have, I'll be helping you to answer that now.
Thank you, sir. Thank you for giving me this opportunity and tell some where I can lack. So thanks for giving a good feedback. But I am a fresher and I am a passed out in 2024.
Mm.
But I am very hard. It is difficult to get into industry. The industry wants below 23 passed outs and below 22
Understood.
passed outs. How can I
That
enter into industry or I can wait for 2 years?
no, no, you don't
Confusing
need
with this
to
question.
wait. Actually, see what actually happens is that there is something called a service based in companies and product based company. See, product based
Right.
company always prefer for the fresh pass outs, 25, 26, 24. But the service company prefer for the lower because they want to put a fake experience for you and push you to the client. This is what exactly happens. So if you are 2022 pass out, they'll put you are 2026, right? So they'll say 3 years this person has worked in our company, and they'll put a fake experience for you, and they'll ask you to crack an interview, which if you crack, you will be put into client. This is how service industry works. But product is not
Okay.
like that. Product is the ones that are looking for fresh pass out with very good knowledge. But unfortunately, product company won't hire many from tier 2 tier 3 college. They always go for tier 1 and top college, IIT, ISC, NIT, VIT, BITS, like this. So MIT,
Okay.
so some very top colleges. So that's why getting a job is difficult. But the thing what I would suggest you is go to make a list of 30 companies, top 30 companies, be it anything, Apple, Google, Facebook, Qualcomm, Broadcom, MediaTek, Nvidia, uh, AMD, ARM, all of these companies. I named 10 here only. So make all the top 10 product company list, top 30 product company list, go to their career website, look for the
Okay.
role that suits you as a physical design engineer and one year of experience. Take the job description, put it into AI, and ask the AI to build a resume according to the job description. Take that resume, take the resume which you have built, give both of them to your AI, ask the AI to club both of them, and it will
Okay.
give you a fresh resume. Take that resume, try to read and understand each line, and tweak means and change those lines according to your convenient, means according to the way it means. It should not completely look like it is generated resume, or it should not look like it you have completely written by your hand. It should be in between of them. Okay, 60% you have done, 30-40% the AI has done. This way it has to be. Make that way
Okay.
of resume and apply to that company on the career portal itself, or
Okay.
contact someone on LinkedIn who is working in that company. Okay,
Okay.
this way you can enter product company itself, and product company, to be frank, pays really good amount of money or good salary than a service company pays.
Okay.
Getting there is difficult because you have to fight with IIT people, ISC people, NIT people, VIT, BITS, any top colleges.
You're right.
But if you get in, you'll be settled very well if you are going to perform very well there. and you can reach very good positions if you are consistently performing there. That's all that matters. Okay, getting there is difficult. It's not like nobody has got into those companies with tier 2, tier 3 college. There are people. The companies need a skill. Okay, try this way. Parallelly, keep
Okay.
looking for any service company that is going to hire you. Send it to all the service companies. Again, make a list of 30 companies. Look for their career portal or their website. Take the HR email ID. Send your resume. Draft a very
Okay.
good cover page or content email body for that. Attach your resume. Send it. So mention that I
Okay.
are so and so, so and so and all, and send it. By doing this way, you can have the exposure to a lot of area. Means the companies where you can apply. So by this way you can do, and for sure, see after doing this video, I'll be putting it on YouTube, and I'll be posting a LinkedIn post mentioning that you are open for a video and I have done an assessment. So if anybody who is going to come from my come to me for your resume, I'm going to forward. I'll help you in that. That's not a problem. I'll do my
Okay.
best. But you
Okay.
also
Thank
have
you.
to do your part. And
Yeah.
parallelly,
Yeah.
it's not only about sending a resume. It should be like the what you put in your resume, you need to know everything in your resume. Even if you
Yes.
give, if you put like congestion, everything about congestion. And master a single concept each day. You prepare 2 sessions in a day. Morning session, afternoon session. Every time once you sit, take one concept, master it. Floor plan, you have to master floor plan in 2 sessions. Everything
Okay.
about floor plan. Open 10 to 12 websites of related to VLSI. Learn all of them. This way you can prepare. The second way is the LinkedIn and other way to do this. Apart from this,
Okay.
contact your seniors, juniors, and your colleagues who are working in any product company, especially in VLSI. Ask them to
Okay.
refer. Ask them, is there any opening? By this way, you can get into VLSI. And the other thing is, in on LinkedIn, if you are applying for service company, apply for all the service company. See, even a small company can get you a job, because I got my first job through a small company only, not a big company.
Okay.
Very small company it was, and it is really good company. Usually people
Okay.
judge the company based on the size, based on the area, and based on the company owner. But there are
Okay.
some really good companies that are really good, and there are some really bad companies which I have experienced in my life before joining the present company or anything. Before that, I have very bad experience with one company. So be aware of
Okay.
that company. Don't join any company that is going to ask you to be there without salary. If a company is asking you to come in and join but will not give you salary, don't join. You
Okay.
have
Okay.
paid your engineering fees and learned, right? You are not going to serve them, and he is
You're
not
right.
your relative, so you can go and do something free for them. If you are going there, get paid. Okay, and know
Right.
your worth. Don't, if someone says that no, if you say like this, if someone say okay, don't join, then fine, don't join, because those type of company will never grow in the industry. Okay, have this knowledge. If a company says that you have to, you come and join, will not give you offer letter or anything, but you after 3 months will give you salary, or after 3 months we'll see, no, don't join. There are a lot of companies in Bangalore. Every from if you start from your Silk Board to KR Puram, there are a lot of companies for VLSI. Don't need to worry. If not you, there is another company. Tell them on the face and never join that company again if a
Okay.
company is not paying you, because you are worth spending a small amount for the company. It's not like you, this one thing you do, prepare, and the other thing what I said, use the LinkedIn and your contacts. This way you can get a job. It's not that you'll get a job tomorrow morning only. It takes some time. Okay, take
Okay.
some time. Sometimes you might get in a week, sometimes you might get in a month, you might get in a year, sometimes the other way. Analyze your situation. You do, if you are able to do this, you can get a job. If not, if you are struggling, if you're still not getting a job, let's see, I'll try my best, let's see you try your best, and parallelly keep doing something which is related to your industry. Something maybe
Okay.
reading IEEE papers, if you can read IEEE paper, related to your
Okay.
semiconductor. Read the news about semiconductor industry. See, these will help you some or the other way. Try to understand the new concepts in VLSI. If possible, teach someone who is not able to understand something, some concept. If you're good at flow plan, if someone is not able to understand, go and teach them. It will enhance your knowledge also. Okay.
Right.
This way you can get into VLSI. The moment you get into industry, ping me. Let's see. I'll congratulate you. Okay. For any company you're
Okay.
joining. But give
Okay.
your best. That's the one
Okay.
thing, because the competition in VLSI is increasing day by day. Before it
Yeah.
was not like this. From 5 years or post COVID, it is increasing rapidly.
Yeah.
Okay. So the thing
Okay.
is, survival is important. You'll get it, you will get rewarded. Don't leave the hopes.
Okay.
You have a
Okay.
good motive to be in this industry, so keep it going. Okay.
Okay.
Any other questions?
Sir, I already sent resume to you. Is there any modifications to
I'll
or
see.
is it?
See, actually, the resumes what you are sending, right? What you are showing me is all like from a very uh, different kind of resume. See, in this usually, I'll just tell you, you have put your summary, that is fine. Education, you always put at the last.
Okay.
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 Technical. After summary, put technical skills. Then you put your professional training, projects. Instead of professional training, put projects. Summary,
Okay.
technical skill, project, then professional training, then your education, then your certifications. Okay.
Okay. Okay. Okay.
Education and certifications, you put all it together one only. Okay. So this will help you, I guess, because see, resume matters a lot. Because if you send a
Right,
resume
sir.
to any product company, they will not visit your resume one by one. They'll put all the resumes into one folder. That also they won't do. While filling the form only, it will get into one folder dumped. They'll just give some commands and they'll put it into redirect it through a software where it will try to match the keywords. First thing is you have to match the keyword. CTS, routing, floor plan, area, die, core size, placement, congestion, all the keywords related to your PNR or PD is there, right? Use as much
Right.
keywords as possible in your resume. So the tool will try to identify the keywords in it. It will see what is the percentage of keywords matching in your resume. So if it is really good and if it looks like more, and then it will shortlist. Once it gets shortlisted, assume there are 1,000 resumes coming in. It might shortlist around 130 resumes out of 130. Again, the manual process might happen, and then you might be called for an interview. So make sure that you stand unique. The other thing is, don't share your resume for anybody, even for reference purpose,
Okay, sir.
not to your friend also, because he is another
Okay.
competitor for you. Until and unless you get into any company, you don't share him. Once you get into company, you share him. That's fine. For
Okay.
reference, you
Okay.
can share. But if you don't, if you both are preparing and if you both are making the same resume, either of you will be selected or both might be rejected because resume looks same, right?
Yeah, right.
So
Right.
resume is like your Aadhaar card. It should be unique.
Okay.
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 If it is
Thank you.
same, both will get the same benefit, or both might not get the
Yeah.
same benefit. Understood, right?
Okay.
So do
Right.
that
Right.
thing. Rest we'll see what we can do. Keep preparing.
Okay.
Okay.
Yes.
So resume wise, yeah, this is what things you change. As I said, AI is more better for you to analyze your resume than me. Just put your
Yeah.
resume, tell it, please analyze my resume and let me know what changes I have to do. Is this resume easy? Is this resume feasible to go through give any company name? Assume, is this resume going, can I get an interview call by using this resume from so and so company?
Okay, sir.
AI will analyze and give you the data. This is a privilege for you. Okay. Use that tool. Use it like anything.
Okay.
Ask every single question. And you see, you said that you couldn't understand more about latch of effect and all. So put that question and ask AI to answer it. It will give you a video answer. One concept a day, two concept a day, or two, three concepts in a one session is enough. Okay. Prepare well. You
Okay.
can do it. Yeah. Be aware of service company. Apply for product company. There are really good service companies also. Don't forget that there are really good. Apply for them also
Okay,
and
sir.
prepare well. Okay.
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 Thank you, sir. Thank you giving a wonderful opportunity and giving a good feedback for me. Will be very helpful for me, sir. Thank you for this giving me this opportunity, sir. Thank you.
Sure, sure. And you subscribe to my channel. This is called Semitech
Yeah,
Talk. It's on YouTube.
I
Okay,
already,
you
I
watch those
already,
videos because this will help you, I guess. I just made it on the for the purpose of people who are entering the VLSI. That's the main, because when I entered, I didn't have this much knowledge at that time. I wanted someone to help me like this. I
okay,
couldn't get that, so I have made it. That's it. There is nothing like I need to earn from YouTube. By God's grace, He is keeping me well with the salary. I'm happy with that. Okay, just do
right,
it, and whoever are in need, ask them to take it up. Okay,
okay, sir. Thank you, sir.
fine,
Thank
fine,
you,
Madhu. Thank you.
thank you, sir.
All the best. Enjoy.
Okay, sir. Thank you, sir.
Okay, bye.